Mathlab activity number 7 to give a suggested demonstration of the formula of the surface area of a sphere. So we will do the surface area of a sphere by some experiment. This is a sphere. You know that this is sphere having the center and the radius. This is a 3D figure, and the surface area of a sphere is 4 pi r square. The cylinder is twice the length needed to cover the hemisphere. If hemisphere is having radius r, and if we take another one cylinder of double of its radius, this is r, so height of the cylinder is 2r and radius is same, so the cylinder is twice the length needed to cover the sphere. Since the thickness of the thread is uniform and same for both the threads, surface area are proportional to the length of the threads approximately. So by this thread we made this one, and the same thread is used to make this one. That means the surface area of this sphere and surface area of this cylinder are equal. On this basis we will do the activity. Materials required: hollow sphere cut into two hemispheres, cylinder with both base diameter and height equal to the diameter of the sphere. These two you can make with the paper, one hemisphere and one cylinder, and you can stick in your practical notebook by making the crease up. Okay, got it? So take a roll, not roll, we cannot take the roll and we just make the two and then we do it. But you should write, take a roll of thread and wind it closely to the surface of the hemisphere completely. You can do it. And take another roll of the thread and wind it completely along the curved surface of the cylinder. Compare the length of the two threads. So you have to take the two threads, one completely cover the surface area of hemisphere, another completely cover the curved surface area of the cylinder. So you will find the length of the threads are equal. So that proves that these two 3D figures will have same surface area, but the condition is that a cylinder having the diameter and height equal to the diameter of the sphere. Then only it is possible. So you will observe that used to cover the surface is twice the length needed to cover the hemisphere. Length of the thread used to cover the surface area of the cylinder will be the twice double. Okay, so half is the surface area of the hemisphere is equal to half the surface area of the cylinder. Surface area of the cylinder is 2 pi r h divided by 2 pi r h, and h is equal to 2r because we have taken that height of the cylinder equal to the hemisphere, so we can put 2r, so 2 pi r square. So area of the hemisphere is 2 pi r square, and surface area of a sphere, double of it, you will get the surface area of the sphere. Okay, now we will do it. Like this, you can see to give a suggestive demonstration of the formula of the radius of the surface area of an area of a sphere in terms of its radius. You can see this demonstration where they have just complete by using the wire, and same wire has been taken with the same length and finish it like this. we can start doing it. Okay. So check the two boxes in the tool box to generate hemisphere and cylinder. This is when you click, you will get hemisphere of radius r, and click here, you will get the cylinder of height 2r and radius same. Click on next. Okay. Now drag these jute threads of length L over these figures to wind them completely. This one we will wind. We can wind like this thread, or we can take some, if we have a solid these two figures, we can use wire also, but any thread, you can take the thread of having more diameter, then it becomes easy to make it like this. Okay. So this every thread is having how much length? L length, same length. The first one we have to wind on the surface of hemisphere. Second, again we will take this and wind on this. So it will not cover full surface, half surface, and both are having same length. So this will be L length, this will be 2L length. Another one, wind them completely, both figures. So we use the two bundles of thread to wind on cylinder as compared to hemisphere. Hemisphere we use only one bundle. So that means it is double. The surface area of cylinder is double the surface area of hemisphere. Now compare the length of the thread used to wind the hemisphere, thread used to wind the cylinder, 2L, and this is L. For the length of the cylinder thread is equal to 2 times the length of hemispherical thread, and length of the thread is equal to the surface area of cylinder. Okay, next. And height of the cylinder is 2r, then surface area of hemisphere is equal to 1 by 2 surface area of cylinder. The surface area of cylinder is pi 1 by 2. Surface area of cylinder is 2 pi RH. So 1 by 2 2 pi RH. This is wrong. Only 1 by 2. Here it is 1 by 2 only. This one is wrong. Huh? So pi 2 will cancel. Cancelled. They cancelled actually this one. But by mistake it is looking like here also. But this sign is for cancelling these two. It is surface area 1 by 2 surface area of a cylinder is 2 pi r h, and this two cancel. This line is for cancelling them. So we get pi r h, and height of cylinder is equal to 2r. Therefore here pi r into 2r, and this r should be same. So we will take capital R, both capital R or both small r. Huh? So both we are taking capital R. So this will become 2 pi r square. 2 pi r square surface area of hemisphere. Therefore, the surface area of sphere, will be equal to 2 times the surface area of hemisphere. 2 pi r square, 2 to the 4 pi r square. So hence prove that the volume of a sphere is 4 pi r square. Self-evaluation. Yes. Now you have to tell me the answers. In a sphere, radius is 85. Calculate the sphere's surface area. Radius is 85. Then surface area is 4 pi r square. 4 pi r square.
Sir, 90746.
90746. And if radius is 49, yes,
Sir, 30156.56.
3015. When radius is 19, all questions are same.
Sir, I think it's none of these because the answer I got was 4534.1.
What is the next 6 inches?
Radius 6 inches. Sir, 30 or 36 into 4. 144 pi inches square.
Last,
1 second, sir. Let me just calculate. Sir, 5544 centimeters square.
Okay. Okay. So all answers are correct.